It's called an IVP, an initial value problem. All that means is they're giving you the value to find C. So the first thing you have to do is find the antiderivative. And this is the power rule. So you're gonna add 1 to the fraction. You're gonna divide by the new fraction. That 9 is out in front plus C. So hopefully that's pretty familiar to you. Ends up being 9x to the 1 over 13 power. This is the 1 over 13 power. So you end up multiplying 13 by 9, and you get 117x 1 over 13 plus C, like that.
Okay.
And then to find C, use that initial condition. So you use that part here where it says, okay, x is -1, y is -6. Sorry for scrolling. 117, -1 to the 1 over 13 power plus C, like that.
All right.
And if you haven't done this in a while, this 1 over 13 power means the 13th root of
Okay.
-1, which is -1. So, and then you add that to the other side of the equation. So C equals 111. So your final answer, I guess you just need the part to the right of it, 117x to the 1 over 13 plus 111, like that. Please check that if you don't mind. And maybe more importantly, let me know if you have any questions about steps there.
Yeah, it said it was right. I get it. Yeah, I get it. These were just like ones I think it had been a while since I had done them. So
Sure. Yeah.
yeah.
My glad to help. Next one here is, all right, so this is I made a comment about this kind of being awkward. This is 42. I guess I didn't write down which number that was. Sorry
I
about
found
that.
it. You're okay.
Okay. Okay. I made some comment yesterday about like this is usually you get something a little bit more sophisticated. So whenever you're taking the derivative of the integral, so this is derivative of the integral, what you do is you take this top thing and you put it in for the variable. So it becomes 1 over square root 1 minus sine squared x, like that, and it has to be x. And then you multiply by the derivative of whatever this thing is. Derivative of sine is cosine. And that is your final answer. So it's a recipe that you have to remember. If you remember yesterday, I think we just put like x in and then you multiplied by 1, which didn't do anything.
Okay.
Next one here. This is number 10. Find all possible functions with a given derivative. Then your multiple choice final, you will take derivatives maybe. Here you
Yeah.
might rewrite it just to get it in a form that's a little bit better.
Okay.
As a reminder, when it's a constant times dx, it's kx. So this first one becomes minus 5x when you find the antiderivative. The second one here is the power rule. You add 1 to the exponent and divide by the new exponent. So that's minus 5x minus 4x to the minus 1 over minus 1. So you end up getting minus 5x plus 4 over x, like that.
Okay.
Because it's x to the minus 1, it becomes over x. And maybe
Mhm.
just write this a little better. Plus c.
Yeah, says it was right.
Great. All right, so next one here is 44. 44 is a u substitution. So u in this case is 4x minus 3, and u is 4 dx. The reason it's a u is you actually know the integral of secant u tangent u. That's
Mm-hmm.
one of those to remember.
Okay.
If you can get it into that form, then you can take the antiderivative of it. All right, and then you solve for dx. Dx is du over 4. And then so you always back substitute. So this is close. It's secant u, tangent u, and then instead of dx, it's du over 4. And so the integral, it's 1/4 the integral secant u, tangent u, du. And then that antiderivative is secant u plus c. And then you have to back substitute. So you have to take this u and put it back, and you have to go back to x here. I guess I snipped, or maybe it snipped off. So the answer here is 1/4 secant 4x minus 3 plus c.
Okay, it says it was correct.
Great. All right, next problem I have here is 5. 5, okay. Critical points. There's two ways to do this. All right, so the one is to graph and look for like peaks and valleys. The other way is to take the derivative and set it equal to 0. Which do you think you'll do? I don't recall.
Say it again.
Which do you think you will do? Like, do you think you'll graph it, or do you think you'll take the derivative?
Well, today I did this one a couple times, and when I graphed it, I couldn't I don't know why I couldn't get the domain to look like there was any critical points. I
All
don't
right,
know.
so
I'm
do you want me?
struggling.
I can let me graph it for you. Let me go to my TI-83. here and see if I can help. So I got to do a little cleanup here because it's helping another student and you don't need to see stuff that they're doing. Okay, so x squared plus 250 over x. And then if you just graph it, like that's a terrible thing to do. Like even if you have a standard window, it's just
Mm-hmm.
terrible. So what you want to do is do a zoom fit.
Okay.
And what the calculator tries to do is it tries to like pick a window that it thinks you want. Now, this isn't great, but you can kind of see it comes down and comes back, starts to come back up.
Mm-hmm.
And this is where you can go to your window and do some things here. So like X needs to go, we'll go from like 0. Let's go out like, I don't know, I'm gonna go out like a bit more. Let's go out to like 25. And then Y min, I'm gonna go to 0 to 1,000. I like kind of picking nice numbers. That's too far. Now when I graph, I can kind of see it there.
Mm-hmm. Okay.
And then you can do the second out min, but you got to do the whole left bound, right bound thing. Do you
Mm-hmm.
know about this?
Yes, I do.
Okay. And you can trace to find it. You can actually just put in number. Looks like it's going to be, but it doesn't always like end up being a nice number. This time it is, it's at 5. So that is the critical point.
Okay. Okay, that makes it better as far as graphing because I was struggling with that.
Yes. So that zoom fit kind of worked. Um, like I don't know, it's like setting the filters on your dating app to the extremes and you maybe not you, but a person. You get to see everything. So
Yeah.
all right. So that is the only answer that worked.
Okay. Perfect. It says it worked.
Great.
So
47 is what I see next. I'm going to actually take 30 seconds here.
okay.
And I'll be right back. Got a cat that needs food, so I'll be right back.
Okay.
Right, I am back. Thank you. She likes to bite if I don't feed her. That's bad for the lessons. Okay. The first thing here is that you can process of elimination, you can remove these because it's the integral from 6 to 12. So that means that one's out and that one's out. Do you see that? Why that would be? Is that clear?
Um, I all I see is the calculator.
Oh, I apologize. Yes, I have been known to do that. So what did you miss on this one? You didn't miss anything on that one. Okay. Yes, 47 here. The 6 to 12 becomes the integral from 6 to 12. You cross out the 2 that it can't be. And so
Mhm.
you're down to A or C. And then this the CK right here is your X. So it's really 7X to the 6th. And that should be
Okay.
enough for your final answer for that.
Okay.
Let me know if that doesn't work, and I can revise what I've
No, it
said here.
works. Yeah.
Okay. Okay. All right. 45. We will be using the calculator for this for sure. whenever it's kind of a numerical answer. So this actually is a problem where we're going to kind of modify a little bit. So if you remember, I said things like, okay, it's always the integral of top minus bottom. Now, see how though there's a switch, like the top is the line, the bottom is the curve. But then in this region, the top is the curve and the bottom is the line. And then it switches again
Mm-hmm.
to what's different here. So to avoid issues, you can always put the absolute value around your integral. And so I'll show you that here because you're integrating from -9 to 9. Top, your top changes. So the order doesn't matter now. You're going to go 9 minus x minus 81 minus x squared, but you're going to put it in absolute value. An absolute value, I believe, is under math button. If you're not sure where to go for that, let's see here. Math, num abs. There we go. Num abs. You'll see that.
Math.
But you
No.
have to do you have to do the integral, put your -9 to 9 in, but if you put absolute value around it, you will always get the right answer. You don't have to figure out which is the top or which is the bottom.
Okay. Oops. Fine. And then math. No. Absolute. Okay. Enter. I got, oh my gosh, like a huge number.
Good. Make sure you got parentheses in the right places. Um, shouldn't be that large. Like it should be,
I got like 827.
and maybe do well, take a look here. I mean, so if we just say, I don't know, 18 times, it should be around 1200-ish. I don't know. You said, what did you get? Eight something?
827.6, but it's like continuing. Like,
Okay, so that's when you do a math enter.
yeah, and I got, oh my gosh, 413830850 over 499997. Is that right?
Yeah, that doesn't sound right. But let me look. I didn't quite get to all the way in. Got that cat. He just doesn't understand that minus. Yeah, so I think you have like an imbalance and so your integral -9, it's gonna be like, does yours put in the vertical bars?
Yes, it did.
And you have parentheses 9 minus x, close parentheses, minus parentheses 81 minus x squared, close parentheses.
Yes.
And from -9 to 9.
Yeah.
Okay, I got 2483 divided by 3,
Okay.
which is 827-ish, but I just did, yeah, maybe did you immediately do a math enter, or did you like copy the number and do a math enter?
I immediately did it. I don't know. Maybe my
Okay.
calculator's being weird. I don't know.
Well, the nice thing is on the multiple choices, you'll just get that number and this one will be really close and you'll say, yep, that's it. I got it.
Yeah. Okay.
So I think that is everything. We
Okay.
obviously have some time. You have some other things you want us to look at tonight?
I don't think so. I think I went through all of it and everything else I'm pretty sure I can do, or they're repeats of other things.
Okay.
So yeah, I think
You have
I'm
to get
good
like,
for today. An
are you
80.
sure? Just, yeah, I know you're just trying to clear that threshold, to open up the exam there. I've helped a lot of people in real life over the years.
Yeah.
All right. Okay. Well, we can stop here if that's what